honest with you, most of the stuff that we talk about in this section is mainly logic oriented, which means you basically could kind of figure it out if you had to on your own. Okay? It's not one that takes a lot of brain power to get through, shall we say. So the easiest thing to start with on this is just to think of this. True or false? True. It's true. Okay. 3 plus 7 is 10. Last time I checked, that's how math works. When you take two smaller parts and you add them together, the sum is greater than either one of the small ones. Now, we've done this with segments. We've done this with... Okay, cool, thank you. We've done this with segments. Let's put away the book and the earbuds. Come on. Thank you, sir. Because I know people have been emailing me about stuff like that. All right, so let's put it away. Now, the reason why I wanted to show with that is because anytime you add something together, this sum is always larger than either one of the two. Thanks. The other thing that comes with that is when you start looking at it in terms of the triangles. And again, this is something pretty simple to think about. What kind of an angle is that angle number 3? What do we call it? Remember what we called that? Exterior. Good. We called it an exterior angle. The exterior angle always equals the sum of the two angles not touched. Remember that? So whenever we're dealing with with exterior angle stuff, remember, we've seen this many times. It's always equal to the sum of the two it doesn't touch, which means this outside angle will always be greater than either one of those. It's kind of what they introduced it to you with. The idea of how things add up to be bigger than what the other parts are. Since the exterior angle, that angle 3, the exterior angle, let me rewrite this, will always be greater than either two angles it doesn't touch. That outside angle will always be bigger than either of the two angles it doesn't touch. It makes total sense to start thinking about it. Like I said, it is mainly a logic thing as opposed to a straight on math thing you have to set up. Because what we're going to wind up doing with this is quite literally which angle is bigger than that kind of stuff. Which things need to set up. When you take your hand, can you guys make a 90-degree angle?
Yeah.
Show me. Okay. Now, if you make a 90-degree angle, they're about this far apart, right? Now, what would 45 degrees look like? About half of it, right? What happened to the length between your fingertips? You got smaller, right? Go back to the 90. What happens? Show me a 90-degree angle. Yes. What I'm getting at here is this, guys. As you go through a triangle, that's a 90-degree angle, right? 80 degrees would just be about a smidge less than it. Okay? If I'm saying that's approximately 80 degrees, what would 40 degrees look like? Half of that, right? Smaller, right? 60 would be a little bit bigger than it. So what I'm getting at here is the larger the angle, what happens to the side length across from it? The larger the angle, what about the side across from it? The larger the angle, what about the side across from it? Doesn't it look like it's getting larger? So if I'm going this way, the angle is getting larger, right?
You said if the angle is 90 degrees,
No. What I'm saying is if the angle gets larger, what happens to the side across from it? An angle. If the angle gets bigger, what happens to the side across from the angle? That's what I'm saying. This. What's happening here? What's happening in the angle? So, as the angle gets bigger, the side length gets bigger. That's where we're going with that. Yeah. Anyway, so what this means, and we've kind of mentioned this before, the larger angles the angle, the longer the side length across from it. Which means you can put things in order. You can list the order in which the sides are longer, or put them in. You guys know the difference between ascending or descending? What is it? Going up. Okay, so if I wanted to say that, if I wanted to put these side lengths in ascending order, I want to say I'm going to put them in ascending order. That means am I starting with the biggest or the smallest? The smallest. So which one's got to be the smallest side length? What is it? Well, angle B is the smallest, which means what's the side length? AC. So the smallest side length would be AC. And then the next one would be AB. And then the last one, the longest one, would be okay. Again, not really all that difficult, is it? It makes common sense. And guess what? It works going backwards. I know. I think it's my shoe.
We like shoe.
Oh, it's my shoe. Show me a right angle. Why not? Are you going to show me a right angle? I can't. I didn't see where you were pointing. Fine, you can come. Okay. Which of those side lengths is the longest? The 12, right? Which means what's got to be the biggest angle? Okay. That's the relationship between angles and sides whenever you're in a triangle. Always works that way. It always works that way. Largest angle is always across from the longest side. The smallest angle is always across from the short side. And then obviously by process of elimination, it's just logic really, guys, as it gets into it. Now, the other part of this goes, What happens if you have an isosceles triangle? If you have an isosceles triangle, it means you have two sides that are the same, which means you're going to have two angles that are the same. That's why this all works. Now, when you have an isosceles triangle, those two side lengths, they could be smaller than a different side. They could be larger than a different side. It all depends upon the values that they give you. Which means that there has to be some sort of a parameter so that you can actually create a triangle. Because sometimes you can't. Okay? For example, how do you know if you can make a triangle? Well, what happens here, if I go back to the example I was just talking about, I had side lengths of what? 12, 7, and 8, I believe.
Yeah.
The reason why I can make a triangle with those side lengths is because anytime you add two of them together, it's always greater than the third. Exactly. Every time you add, in order to make a triangle, the sum of two sides must be, oops, right? In order to make a triangle, the sum of any two sides must be greater than the third, otherwise it won't work. Basically, you're doing this. You're asking, is 12 plus 7 greater than 8? Is 7 plus 8 greater than 12? And is 8 plus 12 greater than 7? All three of those have to be true. Okay? All three of those would have to be considered what we call a true statement. And it's quite literally just quick additions here, guys. 12 plus 7. Yes, please. It's greater than 8. Good, but what is it? 19. Is 19 larger than 8?
Yes.
7 plus 8. Is 15 bigger than 12?
Yeah.
Is 20 larger than 7?
Yeah.
So as long as all three of those give you a true statement, you can create a triangle with those side lengths. Okay. What? Like I said, this is horribly difficult. I really hope you guys do okay with this. You're welcome. I was worried about you.
Yeah, I can see why.
Skip all this. Eat it. Oop. So, oops. Can I make? Can I make a triangle? Sorry. Can I make a triangle with those side lengths?
Wait. Can that be?
Is that greater than?
No,
No.
I'm
Right.
You can. That's not
Yeah, that's
true.
what we're doing.
These two are all both okay, but 15 is not greater than 15. So can I make a triangle out of that?
No.
Reason is, if you think about it, when you have a ruler, you guys agree that's a side line? Side length, right?
Yeah.
Okay. You agree that these are side lengths? Okay. There's the bottom of the triangle. Here's the two side lengths that have equal equal the other side length. They're trying to put them on the edges to fold them over. It just plays flat, which means you just get seconds on top of seconds. It means you don't get a triangle. That's why that doesn't work.
Thank you.
Okay. Now, that allows you then to be able to do something like this. Values of x, what are possible values of x that you could make a triangle with two other sides of 15 and 8?
9.
What are the possible values? Now, think about what we were doing here the last couple examples. The last couple examples, we wrote out 3 inequalities. Can't I just write down 3 different inequalities again with the value of x? But you watch what happens. Like I was saying, you're going to want to write out there are 3 separate inequalities that you could have. When you solve an inequality, you solve it. When you solve an inequality, you solve it the exact same you would, or exact same way you would if it was a regular equation. Only thing you have to worry about is if you're multiplying or dividing by a negative. In this case, you're not doing any of that, so you have to turn. So subtract it over. What's 8 minus 15? No, it's not 6. It's negative, right? It's negative 7. And I have negative segment length. No, so I throw this one out. What's 15 plus 8? And what's 15 minus 8? Okay. Now, normally when we write these things out, that tells me that we get any value of x that's bigger than 7, or any value of x that's smaller than 23. Do you guys remember how to read these things backwards? The reason, true or false? If I say that backwards, 1 is less than 3. Is that true or false? Yeah. That's what happens when you rewrite things backwards. So if I write this backwards, x is less than 23, but x has to be greater than 7. So this is what happens here is that you create what's called a compound inequality. Okay. Compound inequality. Small value, large value. Fine. X is greater than 7, but yet it's smaller than 23. When you're writing out these things in terms of these what are called compound inequalities, you're always going to use less than symbols. You will always use less than. Okay? Guarantee some of you guys will screw that up if you didn't put that down. Again, find values of x. Excuse me. Find values of x that help you to create a triangle. The easiest thing to do is quite literally write out 3 inequalities until maybe you might find that there is a special pattern that does exist. It's kind of a little shortcut if you pick up on it. I'm wrong.
I think you're wrong. R-A-W.
Thanks, man.
I think I'm going to name it. I'm just kidding. Actually, I'm just not great at
In between what? Like 2 or 3.8, whatever. Yeah. It doesn't matter. Now, guys, what's happening here?
Yeah.
Moving stuff around, real quick, you'll see you get x has to be greater than 1. This one is x is greater than -1, so I throw that out. And the other one is 19 is greater than x, which means x is less than 19. So it has to be smaller than 19, but bigger than 1. Now look at the numbers that you started with. 9 and 10. How did I get 19? How did I get 1? Yes, I minus them. Otherwise known as subtracted. So what do you think the shortcut would be? Oh, say. Just add them, subtract them. Anytime you have values. Add them. 7. Add them. Not add all. Subtract them. 3. X has to be between 7, 3. Works every time. What happens if one of your side lengths is x plus 1? Because that could be the case as well. I'm just showing you to make sure you understand that you can put them all together. What's that? 2 plus 5. 5 minus 2. There's no guess and check. There's no guess and check. Really, it's quite literally we're doing these steps. Sorry, this one's 7 greater than x. X is greater than -3. Doesn't work. X is greater than 3. It's bigger than 3, smaller than 7. It could be 4, yes. It could be 5. It could be 6.2. Honestly, so more often than not, when people, but you're not the only kid that's ever done that. Going, wait, what? Once you write it, say it one more time, you're like, oh, because you're overthinking it. This is quite literally one of the easiest things we do all year. So there's that. All right. The goofiest part would be this. What does that mean? One's a foot, 2's inches. The weirdest thing that you will see is sometimes they will give you 2 different dimensions, if you will, like feet and inches or feet and yards. Well, I'm going to tell you the ones that I'm going to make sure that you know what they are. The shortcut here is when you're dealing with these, we're still add them and subtract them, but they have to still be the same unit of measure, which means they still have to both be the same units. Remember, it is always easier to use the unit that's smaller. So what's smaller, a foot or an inch? An inch. How many inches are in a foot? So 3 feet is how many inches? So it'll be 36 inches, 20 inches, and x. The ones that I want you guys, that I will hold you accountable for are 12 inches to 1 foot, 3 feet to 1 yard, and 5,280 feet in 1 mile. The rest of them, I'm not worried about.
Wait a minute. I like that.
It's math class, so it happens.
Wait, so 12 inches.
12 inches are in a foot. 3 feet are in a yard. 1,280 feet are in 1 mile.
So is that how many yards are in a mile?
Divide that by 3.
I said, how many yards are in a mile?
Divide that by 3.
What do you mean?
Divide by
Divide 5,280 by 3. Five two eight zero divided by 3. I thought it was 15. Okay. Yeah, it's all it is. Okay. Do these, please. Yeah, I'll put them up here in a second. We'll start with those.